On May 28th, 2026, in Shenzhen, the founder of BYD held up a chip smaller than a coin and called it China's first 4-nanometer intelligent driving chip, built to run self-driving in cars that sell for under $20,000. There is one detail he left out. No factory inside China can actually make it. Wang Chuanfu has a line he keeps repeating. The first half of the car war was about batteries. The second half is about chips. And BYD just made its move. This is not a small company shipping a press release toy. BYD delivered 4.27 million electric vehicles in 2024. That is roughly a quarter of every EV sold on Earth, and about 2.5 times what Tesla shipped that year. When a company that size builds its own silicon, it has millions of cars a year waiting to receive it. The Xuanji A3 is also not a one-off. It's BYD's 567th automotive-grade chip, sitting on top of more than 100 billion yuan, around $14 billion, poured into semiconductors, 5 wafer fabs, and over 7,000 chip engineers. And BYD isn't alone. NIO's self-designed driving chip has already shipped past 550,000 units. Xpeng has crossed 200,000 and won a mass production contract with Volkswagen. A whole row of Chinese car makers stopped buying their brains from Nvidia and started drawing their own. So the story seems to write itself. China caught up. Or did it? So back to the detail from the top. If no Chinese factory can build a 4-nanometer chip, who built this one? Designing a chip and manufacturing one are two completely different jobs. You can draw the most advanced blueprint on the planet, but somebody still has to carve it into silicon at a scale smaller than a virus, and at 4 nanometers, almost nobody on Earth can do that. Quick note on that number. Nanometers are basically a measure of how small and tightly packed a chip's transistors are. And smaller means faster and more advanced, so 4 sits near the bleeding edge. And that is the wall BYD ran into. There are no fabs inside China today that can mass produce a 4-nanometer automotive-grade chip. BYD never said where the Xuanji A3 is built. I went looking, and the company simply does not disclose it. The industry consensus, and I want to be upfront that this is analyst belief and not confirmed fact, is that the actual wafers are cut by TSMC in Taiwan, while BYD does the packaging and testing back home in Chengdu. Take that with a grain of salt, because BYD won't confirm it either way, and BYD is not the odd one out. NIO's self-designed chip already runs on Samsung's 5-nanometer line in South Korea, and the Seoul Economic Daily reports Samsung is now in talks with several Chinese car makers, BYD included, to build their 2 and 4-nanometer driving chips. The pattern is hard to miss. The designs are Chinese. The most advanced silicon is not made in China. To understand why a company that builds millions of cars still can't make its own most advanced chip, you need to know about one machine. It's an extreme ultraviolet lithography system, or EUV for short, and it's built by a single Dutch company called ASML. Translated, it's the printer that stamps the smallest circuits onto a chip. And at the leading edge, it's the only tool that does the job cleanly. China is not allowed to buy one. Since 2019, the United States and the Netherlands, where ASML is based, have worked together to keep EUV machines out of China entirely on national security grounds. ASML has never sold a single EUV system to a Chinese customer. Beijing calls the controls an attempt to strangle its industry and has poured state money into building its own. So far, policy trackers report a prototype from that effort, and nothing in production. So Chinese fabs take the older tool called deep ultraviolet, or DUV, and force it to do a job it was never designed for by running the same wafer through it over and over. To pattern a 7nm chip, an EUV machine needs around 9 passes. Doing it on DUV takes about 34. Every extra pass adds time and money, and each one is another chance to wreck the chip before it's finished, and China did it anyway. This is the part the doom and gloom coverage leaves out. SMIC, the country's top foundry and the exclusive maker of Huawei's Ascend AI chips, reached 7nm, then pushed to a node it markets as 5nm class, without a single EUV machine in the building. On pure engineering, coaxing near 5nm geometry out of DUV is one of the hardest things anyone has pulled off in chip making this decade. But read the fine print. When Tech Insights physically tore that 5nm node apart, they found it lands somewhere between 7 and 5 nanometers, a scaled stretch of the older 7nm process, rather than a true generational leap. So the headline that China made a 5nm chip is doing a lot of quiet work. Then comes the math that never makes the headline. Estimates from chip analysts like SemiAnalysis put SMIC's yield, meaning the share of chips on each wafer that come out actually working, at roughly a quarter to 40% at 7nm and under 20% at the 5nm class node. TSMC runs above 80. Volume makes the picture worse. SMIC turns out a few thousand advanced wafers a month against TSMC's 100,000 and up, close to a 30-to-1 gap. Low yield and low volume compound each other, and every advanced chip SMIC makes costs more and arrives slower than the same chip from Taiwan. That works for Huawei's phones and a state-backed AI program. It is much harder to run a global car maker on it. China sees the bottleneck and is spending straight at it. The third round of its National Chip Fund launched in 2024 at $47.5 billion. But the money bought the blueprint. It can't buy the one machine ASML won't ship. So why is China so advanced? Both things are true at the same time, and most coverage only tells you one. China genuinely leads on design and on vertical integration, meaning companies like BYD design, package, and test a chip almost entirely in-house instead of splitting the work across separate suppliers. It also wrings more out of old equipment than the rest of the industry believed was physically possible. The shipping numbers back that up. The ceiling is just as real. At the leading edge, the yield, the volume, and the economics still sit in Taiwan and South Korea, and a good share of China's self-developed silicon is quietly still cut there. You can watch the same pattern play out a few layers up in AI. In one specific week this past March, Chinese models generated 36% of all the tokens flowing through Open Router, a major model marketplace. It was the third straight week Chinese models had beaten American models there. On scale and on cost, China is winning that fight. On the frontier, even DeepSeek says so itself. When it previewed its newest model, V4, in April, its own technical report admitted the model trails the best from OpenAI and Google by roughly 3 to 6 months. When the lab grades its own work as 3 to 6 months behind, the gap is real. None of this is happening quietly, though. The White House has accused China of industrial-scale theft of American AI technology, which Beijing rejects as groundless. The chips are the ground that fight is being fought on. That's the real shape of it. China can design almost anything. What it still can't fully do is manufacture the hardest version at home, and the Xuanji A3 is the whole race in miniature. A Chinese chip in a Chinese car from a Chinese company that would rather not tell you where it was probably made. Taiwan.